Today's lesson is lesson 6.5a is what I like to call it. It's the first part. In today's lesson, you're simply going to simplify radical expressions, a continuation of what we did yesterday. This will all lead up to tomorrow's lesson, which is to add, subtract, multiply, and divide radical expressions. Now this all has to do with Pascal 1.1b, and you can see right here it says to simplify radical expressions. Okay. First thing we want to cover here is the product property of radicals. This basically says that when you have two radical expressions and the indices or the index are the same, such as the square root of 2 and the square root of 8, we can multiply these radicands together and it's going to be just fine. So, although I can't find the square root of 2 as a rational number, nor can I find the square root of 8, the square root of 16 is 4. And this helps us out in simplifying these things by putting other radicals together. All right? In order for a radical to be in simplest form, the radicand must contain no factors that are the nth power of an integer or polynomial. In other words, the power inside cannot be bigger than the index, cannot be equal to the index. So we're going to start off here with the first one, and we're going to simplify this thing. I always recommend that my students break everything apart. Now 25, of course, 25 is 5 squared. So I'll break that up. A to the 4th is just fine as it is. And b to the 9th is just fine as it is. Okay, now since this is a square root, we're going to take out all the even powers that we can. So 5 squared, the square root of 5 squared is just 5. The square root of a to the 4th, a to the 2nd. Now the square root of b to the 9th. Well, we can't do that, but we could do the square root of b to the 8th. So what I want to do is I want to think of that b to the 9th as being like b to the 8th times b. So when I do that, now I can do the square root of b to the 8th is b to the 4th. And what I'm left with, I've taken care of that, I've taken care of that, I've taken care of that. I'm left with a b inside the radical, so that's going to be part of my answer. So simplified, the square root of 25a to the 4th b to the 9th is 5a squared b to the 4th square root of b. Let's take a look here at our second example. Okay, just like before, I want to break this apart. When I break it apart, I want to break it apart to where I can take my third roots of this thing. So, looking for third roots. Now 125 is 5 to the 3rd power. Alright, 30 can be divided by 3, so I will be able to find the third root of m to the 30th. And p to the 20th, well, I can't find the third root of that, but I could find the third root of p to the 18th. And I'm going to leave over here a p squared, because p to the 18th times p squared is p to the 20th. And then I'm going to go through and I'm going to do the third roots of all these. Third root of 5 to the 3rd is 5. The third root of m to the 30th is m to the 10th. The third root of p to the 18th is p to the 6th. And I'm going to be left over with a third root of p squared. Now always go through and check here to make sure that you don't need any absolute values. That's even, the index is even, that's even, no absolute values necessary there. That's odd, no absolute values necessary there. Since that's an odd number, I won't need absolute values on that one either. Okay, now the next part that I want to cover is this, okay? The index, we're not going to mess with the index today, so forget about that for a second. We just covered this one, okay? The radicand contains no factors that are the nth powers of an integer or polynomial or greater, okay? So notice inside here, I'm left with the second power on a third root. I'm all fine there. Okay, now the second part is dealing with fractions. You're not allowed to have a fraction within the radicand, in other words, no fractions inside of roots, and you can't have any roots in the denominator of the fraction. So we're going to use this concept, the quotient property of radicals. What it says is that when I have two radicals and I'm dividing them and the indices are the same, I could just go ahead and do this instead, the square root of 27 over 3, which gets me that square root of 9, which is easier to find. It allows us to put these together or break them apart, like this one right here is going to be broken apart. Alright? And the second thing, rationalize the denominator. Denominator will get rid of any radicals inside, or any radicals in the denominator of the fraction. I will show you that with this example. Okay, our first one. Step 1, I want to break this apart. So let's break this into 2. The square root of y to the 8th over the square root of x to the 7th. Now obviously, this is a 7. I'm doing a square root, so I'm going to have some stuff left over inside the radical. To keep this from happening, I'm going to use a trick here in which I multiply by 1. Now you've seen this before with working with fractions. And remember, 1 can be written many ways. For example, instead of the number 1, I could write 8 over 8, or I could write 9 over 9, or x over x. But in this problem, I'm going to choose to where it's going to help me the most. I'm going to multiply this by, I've got x to the 7th. If this were x to the 8th, it'd be real nice. So I'm going to multiply this by just x, because x to the 7th times the square root of x is just x to the 8th, and I can do the square root. Whatever you put here, put up here as well. And now we'll go through and we'll multiply this all out. Okay, so what I've got is, put them together, x, y to the 8th, the square root of, over the square root of x to the 8th. And just like we did on the previous examples, I'm going to simplify the top and I'm going to simplify the bottom. Now on the top, I can't do anything with that, x, but I can take out y to the 8th. It becomes y to the 4th. So I've got y to the 4th square root x over, and the square root of x to the 8th is x to the 4th. That was completely simplified. There are no powers in here that are 2 or greater. There are no fractions inside the radical, and there's no radicals in the denominator of my fraction. Okay, let's take a look at this, in which we've got a third root that we're dealing with. The process is just the same as before. Break it apart. This is going to be the third root of 2 over the third root of 9x. Now recall that 9 is 3 squared. That's going to be helpful to us here in a second. Alright, now just like I did before, I'm going to multiply this by 1, but I'm going to choose my 1 carefully. My version of 1, I want to increase the power of the 3 by 1. So I'm going to multiply this by the third root. This is going to increase the power of 3 by 1. I want to increase the power of x by 2. And so on the bottom I will have 3 to the third, x to the third. Whatever goes here also goes up here. 3x squared. Alright, now let's carry through on our multiplication. So this is going to be the third root of, well, looking at this, 2, I can't do anything with that. I can't do anything with the 3, and the x squared I can't pull out of the radical either. So on the top, I'm just going to have 6x squared. On the bottom, I'm going to have the third root of 3 to the third, x to the third, which is going to simplify to give me, the top remains the same, 3, the third root of 6x squared over 3x. So remember that when you're working through these problems, in order for them to be completely simplified, the radicand can have no powers that are greater than or equal to the index. You can have no fractions inside your radicand, and no radicands appear in the denominator of the fraction. That's it for today's lesson. We'll see you tomorrow.